Let's go to page 185 and number 252. So this one, the figure is giving. Okay, so this is B over here, A, B, C, D. Okay, so I have already drawn this extra line already. So this is 3, 4, 12, 13. So first you have to draw this over here, divide into triangles. So this is 3, 4, so this would be a 5. And this is 5, 12, 13, so this is a right triangle right over here. So the area would be the sum of the two triangles. So for this one would be 1/2 base times height. And this one over here, the area would be 1/2 base times height. So K will equal to 30 plus 6. So area will be equal to 36. Okay. Okay, let's go to number 253. So find the total area of the figure giving. So you have this square over here. And this is 25, 15. Okay, again, first you can realize that if this is a right triangle, so from this two this is a spatial triangle. So if you don't know what you do is put an x over here, so you got 15, x and 25. You can factor out the 5, so you get 3, y and 5. So you can see that this would be a 4 and times 5 will give you 20. Okay, so this is 20. And again, you should recognize the spatial triangle. So this would be 8 over here, 8, 15, 17. Okay, so the area would be, the square would be 25 times 25. This area would be 1/2 base times height. And this one would be 1/2 base times height. So area will equal to 625 plus 150 plus 60. So K equal to 835. Okay, let's go to number 254. Find the ratio of the area of an equilateral triangle inside. Okay, equilateral triangle inside a circle. Okay. To the area of a square circumscribed about the same circle. Okay. So you have a, okay, so, okay. So you have the equilateral triangle inside the square, and then you have a square outside. Okay, since you deal with the ratio of the area, you can actually you can assign numbers. Okay, you can use variable if you want to, but you can just assign number. It's a lot easier. So first you draw the median down. Okay, and one thing you need to remember is that for equilateral triangle, okay, the three median will meet in the center, the in center, and this would the centroid. They meet in the centroid, and this would divide into ratio 1 to 2. So if you just put down a number, this would be 1, 1, and this would be a 2. Okay. So by looking at that, the square will have side of 4 on each side. Okay. And then so now you can see the the area of a triangle. Okay, so so this is 3. So this would be so this is a long leg. The short leg you divided 3 by square root of 3. So this would be a square root of 3. Okay. And this would be 2 square root of 3 if you need it. Okay. Anyway, so the area of a triangle would be 1/2. Base would be 2 square root of 3 because this would be square root of 3 times height, and area of a square would be 4 times 4. Okay. So area of a triangle would be, you cancel, you get 3 square root of 3. So the ratio of the two area would be 3 square root of 3 to 16. Okay, let's go to 255. A square is inscribed in a semicircle of radius r. Okay, so let's go ahead and so you have a semicircle. They're a bit off. Okay. Okay, here's a semicircle with radius r. And the square has an area of 8 square. So if the square, the area is 8, that means each side will be square root of 8. Okay. And find the area of the square inscribed in. Okay. So first you have to find out the area, find out the r. Then after that, after you find r, then you're going to find the area of a square inside here. Okay, so basically that's what you have. Okay. So from here, again, let's go and draw the radius. So this would be r. And since this is symmetrical, so if this is square root of 8, this would be square root of 8 over 2. And this would be square root of 8 over 2, half, right? Okay, so from here, you can use a Pythagorean theorem. So you got a squared plus b squared equal to c squared. So r squared equal to square root of 8 over 2 squared plus square root of 8 squared. So r squared equal to 8 over 4 plus 8. So r squared equal to 10. So r equal to square root of 10. So once you find r equal to square root of 10, you can come over here to figure out the area of this square. Okay, so it's easy if you make it looks like a rhombus instead. Okay, so the area of the square would be 1/2 d1 d2. So area would be 1/2. So this is square root of 10. So this would be square root of 10. So the d1 would be 2 square root of 10. And since it's a square, so when you turn it becomes rhombus, and diameter would be the same. Okay? And so this will cancel with that, so this will give you 20. Okay, let's go to 256. Okay, so this picture is giving okay, so you have A, B, C, D, E, F. And what fraction of the total area is, so you're looking for shaded area, okay? So actually it's fairly easy. All you have to do is cut this into triangles and just count the triangles. Okay, so the ratio would be, the total would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So total would be 16 triangles, and the shaded areas, notice there are 3 white triangles, okay? So there are 3 white, that means there are 13 black, right? Or 13 shaded, okay? Or you can just count them, okay? And so that's it. So the ratio of shaded to the whole area is 13/16, okay? So you can just cut up into triangles and just count them. Okay, number 257. Okay, a cow is tied to a corner of a 20-foot by 15-foot shade with a 13-foot rope on a total grazing area. Okay, so in this case, so you have 15 by 20, and your rope is 30. Okay, so that means if you stretch out and it can go into, so this would be 10, okay, and this would be 15 over on this side. Okay, so basically you're gonna have a circle, looks like this, okay, and this would be 30. Okay, then when they get to straight with the building, the rope is going to get caught on the corner, and so if the cow keep going, it will form a quarter of a circle like this, and same thing over here. Okay, and this would be 10, this would be 15, 15. Okay, so the grazing area would be this sector over here, and this sector, and this sector. Okay, so the area would be, this one over here would be pi r square. I'm writing out so easier for me to cancel. So pi r square, and this is 3/4 of the circle, so times by 3/4. So that takes care of the big area over here. Plus the second one, this one over here would be pi r square. Okay, but this is only 1/4 of the circle, so times by 1/4. Okay, now for this one here, the same thing would be pi r square, and it again is 1/4 of the circle. Okay, so now all you have to do is go and work it out. So cancel. So this would be 675 pi, and this one cancel, be 25 pi, and this one it doesn't cancel anything, so it would be 225 pi over 4. And if you put everything in over 4, okay, so you end up, if you add all this together, you end up with 3025 pi over 4. Okay, let's go to 258. Okay, so you have this picture over here. You got A, B, C, D. You have the E over here. And this is 2A, and this is A. So you're looking for the ratio of the area of triangle ACE to the area of the rectangle, okay, ABCD. again, since you're dealing with ratio, you can just put in a number, okay, as long as you keep the correct ratio. So you can go ahead and assign 1 to here, and this one you can, since the A and 2A, you can call it 1 and 2, so this would be a 3, okay? So triangle area ACE would be 1/2 base times height, and the rectangle would be 3 times 1. And so this cancel out, so you're going to get 1 to 3. And if you write in a fractional form, it would be 1/3. Okay, 1 to 3 or 1/3. So again, when you deal with ratio, you can assign any number as long as you keep the ratios correct. And that's it.